Hello, and welcome to my Math Companion. In this video, we'll be discussing the use of the OR keyword in a probability problem, and we'll try to interpret it in a mathematical sense. So let's begin. The question states that in a jar, there are 4 cookies, 7 candies, and 5 chocolates. John takes out an item from the jar. What is the probability that John took out a chocolate or a cookie? So as you can already see, we're dealing with two different items from our sample set. Our sample set contains cookies, candies, and chocolates, and we're dealing with chocolates and cookies instead of just one item from our sample set. So, whenever you see the OR keyword in a probability question, for simpler probability questions, the OR keyword will almost 100% of the time signify the addition of two different probabilities. And if you look at this from a mathematical sense, it means that if you were to just take the probability of one certain event happening, for example, just the probability of John taking out a chocolate, it would obviously be lesser than the probability of John taking out a chocolate or a cookie, since the number of options that you have are increasing. You can now either take out a chocolate or a cookie, which means that you have a higher chance of picking out what you want. Since, as I stated before, the number of items that we're dealing with are increasing, and therefore the probability will also increase. So now one might ask, multiplication also increases the value of a number, so why not multiply two different probabilities instead of adding them? And this comes back to a very important point that I made in the first video of probability, which is that the probability of any event occurring can be between 0 and 1 only. It cannot cross those bounds. And therefore, if we multiply two numbers between 0 and 1, we'll actually get a smaller number than our initial two numbers. For example, if I multiplied 1 divided by 5 and 1 divided by 4, my final answer would be 1 divided by 20, which is much, much smaller than 1 divided by 5 or 1 upon 4. However, if I added 1 divided by 5 and 1 divided by 4, the final answer would be greater than 1 upon 5 and 1 upon 4. It would be 9 upon 20. So that is why we add these two probabilities. So now, coming back to our problem, we must first define our sample space. And in this question, the sample space is simply the sum of the total number of items, regardless of which item it is, whether it's a cookie, candy, or chocolate. So the total number of items is 4 plus 7 plus 5, since we have 4 cookies, 7 candies, and 5 chocolates. And this evaluates to 16 total items, and that's our sample space, 16 items. And our condition is that we need a cookie or a chocolate. And as I stated earlier, the OR keyword mathematically translates to addition. So first we will evaluate the probability for the number of chocolates. And basically what we're going to do is we're going to add the probability for the number of chocolates and the number of cookies. So probability for picking a chocolate, we have done this before. The probability for a single event happening would just be the number of elements satisfying that event in the sample set, in the sample space, upon the total number of elements in our sample space. So the number of elements satisfying the event within our sample space is 5, as we have seen earlier. The number of chocolates is 5, and the total number of elements in the sample space is 16. So that is our probability for picking a chocolate from our jar. Next, we see the number of cookies is 4, and we'll do the same thing. We'll find out the probability of picking a cookie, and that is 4 upon 16, since the number of elements satisfying the event is 4 cookies, since there are 4 cookies in the jar, and the total number of elements is 16. So now we must just add these two probabilities. We must just add these two probabilities to get 9 upon 16 as our final probability. So that's our answer. If you're still confused about why the OR keyword translates to addition and not multiplication, or you have some doubts along those lines, here's a good way to think about it. Let's say that you're going to the clothes shop with your mom, and for the sake of simplicity, let's assume that there are only 5 different t-shirts that fit your size. and they're all of different prices and different colors. And let's say you told your mom that you pointed to a certain t-shirt, and that was the most expensive t-shirt, and you told your mom that, can you please get me that t-shirt? Now, there's a certain chance or certain probability that your mom would get you that t-shirt. But if you told her, can I have, let's say the blue t-shirt was the most expensive one. So let's say you told her, can I have the blue t-shirt or the green t-shirt? There would be a higher probability that she would buy either one of them for you, because you're giving her more options, right? You're giving her a larger range of options. And similarly, if you told her, I want, can you get me either one of these three t-shirts? There would there would be an even higher probability that she would buy one of those t-shirts for you. And I'm going to hint at the "and" keyword here. What do you think would happen if you told your mom, I want this t-shirt, let's say the blue t-shirt and the green t-shirt, right? What would happen to the probability that she gets you both the t-shirts? So that's something that I'll leave to you to think about until we do our video on the "and" keyword. So that is how you solve problems involving the "or" keyword in probability. In the next video, we will be looking at the "and" keyword in probability and how to interpret it in a mathematical sense. And I will be doing questions involving both the keywords as well for those who are interested. So I will see you in the next video.